So we didn't discuss throughput. I think we discussed throughput, right?
We mentioned variation.
Yeah. So anyways, as I mentioned, the throughput is a measure of how many packets are successfully going through the system, right? And why do we have something different from the packet arrival rate to describe the performance? Because as we said, there are possibilities of losing packets in the middle if your buffers gets filled. So you start having dropping of the packets or packets being lost, and then accordingly, the output number of successfully transmitted packets is something different from what you put into the system. That's why we call it throughput. So whatever is going through the system successfully, okay? So again, to measure performance of networks, two parameters. One is how many packets per second are going through all the way from start to end successfully. That's called throughput, and it's measured by packets per second. And the other parameter is how long does it take on the average for one packet until it gets processed, and we call that the packet delay, okay? Those are the two parameters that measures the performance of a network. This is more of the elaboration of the description of the throughput, right? And it talks here about the fact that, again, when you are dealing with throughput, because the possibility of having packet drops is happening randomly, then throughput is also a random parameter that you need eventually to represent it by its average value, okay? By the way, all these things are going to be discussed in more details later on. As I mentioned, all what we are doing right now is taking like a quick cut through for the whole course, and then we'll come back to each one of those and discuss it in much more details as we go through the rest of the lectures, okay? But that cut through is really very useful so you know where we are and what we are talking about, okay? And this slide is describing the fact that in any communication network, again, it's related to the throughput. In any communication network, your performance is eventually restricted by the weakest point of that communication system, okay? So here, for example, the bottleneck is the slowest link among the two of these. Sometimes the bottleneck comes from an intermediate node when it has to deal with processing time and packet transmission delay. So it's not the problem of the link, it's the problem of the node itself. So you can, but the performance eventually is limited by the weakest part of your system. And the way you look at the weakness differs between packet switching and circuit switching. We'll see that when we try to solve some examples. Yes?
So the throughput depends on the weakest part of my system?
Yes, and it depends again on both, the weakest among everything. So nodes and links, because both of them will affect the throughput. Okay? Any other questions? Last is one thing to keep in mind, that in most of our communication networks, it's not just the link itself by its capacity is what you need to consider. You have to also keep in mind how many communication links are sharing the same physical link. So here, for example, even though R is much larger than any other RC, but because this R is shared among many nodes, it might be the bottleneck here. Even though the link itself, the physical link, has a much larger capacity. So the width here means that it has a higher capability of transmission. It has more ability to transmit higher rates, okay? But despite this higher rate is shared among many communication sessions, so it might be that this is the bottleneck, okay? So that's what the objective of this slide, to tell you that when you are looking for the bottleneck, it's not just simply looking at each link capacity and that's it. How many sessions are trying to use that link is also another factor to keep it in mind, okay? Any questions? طيب. Next thing is we move away from, now we have been looking at the different elements of a communication network. So looking at how to measure the performance, what are the types of switching, circuit switching, packet switching, the idea in general of a protocol. Now we will elaborate a little bit more about protocols in terms of how they are represented as multiple layers. The question about, are we going to talk about the layers, okay? So why do we need to represent? First of all, what's a protocol? Does anyone remember what a protocol defines? Descriptive. You don't have to say it. Yeah, go ahead.
It is the way that two nodes or two entities can communicate or agree on a standard in order to
Speak to each other or transfer information. And this includes two important jobs. What are they? So what you said is correct, and that includes two important jobs that we mentioned earlier. What are those two jobs?
Standardization.
Standardization means standardizing what exactly?
Like, for example, like the standard, like standards.
Formatting.
Yeah.
So basically, which we represented it as two humans agreeing on the language, right? So which language you speak. In that case, how does your packet look like? The first few bits means what? The next ones means what? Where is the information? Where is the header? How big is the header? And so on, right? So the first job is formatting, right? The second is,
When one talks.
we didn't call it priority, we called it who speaks when, we called it what? Order, right? So who, order means the two things. Who goes first, who goes second, or order, it means for things to be organized, right? You know when they knock on the court and they say order, right? Because want everyone to talk at their time or stay within the organizational definition, right? So those are the two functions of a protocol, right? Who speaks when? We call that order. What language do we speak? We call that the formatting of the communication packets, okay, or data. Okay. Now, we need still to do one more organizational step on protocols, which is defining them over layers. Why do we need layers? Because we will end up anyways, when we deal with our day-to-day networks, with engineers working at different hierarchies. I'm not talking about the hierarchies within the job, but I'm talking about technical hierarchies. For example, if you are developing a mail client, right? Why do you care when you are writing a software to develop a mail client, a client that can send emails and receive emails from a mail server, right? Should you really care about whether your connection is wireless or wired, or whether that connection is using 5 volts to represent 1 bit and minus 5 volts or 0 volts to represent a 0 bit and so on? You shouldn't, right? To enable this hierarchical thinking or thinking at the level that you are working at or developing at, we need to break the operation of network protocols into layers. And when you are developing something for a particular layer, you don't really care about what happens at the other layers. You just need to make sure that you can speak correctly to your corresponding same layer on the other side of the communication, and then you leave handling the rest of the other layers to people who work on those layers. Maybe what I'm saying right now is not gonna be clear until we look at the layers and then understand how a communication system works within a layered system, then this will become clear. So let's look at layers, and there are two ways to look at this. There is one way that evolved naturally, which is the evolution of layers within the internet, and then later on came the standard organization, the ISO, the International Standardization Organization. Everyone heard the ISO because it's everywhere in the industry, right? And they created a standardized layering model for communication networks. They call it the OSI, the Open System Interconnect. So the formally standardized one is called the ISO OSI, ISO OSI, Open System Interconnect. Okay, and that one is composed of 7 layers. We will talk about them in a couple of slides. The one that evolved naturally with the evolution of the internet, which is the internet layering, is actually composed of, so the internet, 5 layers only. And those 5 layers, they exist within the 7, and the 7 added 2 more layers in the whole model, okay? So we will look at this quickly from a general perspective, and we'll revisit that later as we go through the course. Okay? So here is the internet, 5 layers, and it's easier to start with this one. This is easy to map to what we are doing actually when we are communicating through the internet network, okay, or communication network. The first one, the lowest one, is the physical. The physical is the one concerned about defining the electricity and magnetism as well as the communication things that you studied in your communication course. So things like, okay, if I need to connect to Ethernet, I have to have a cable with this certain specifications, with the cords that looks like twisted pair, and the port at the end of that cable, the physical port, should look like the RG45 right connection, which has certain pins, and the signal that goes across each one of those pins has the following specifications. Voltage should be this when you are representing a 1, and should be that when you are representing a 0. The information that I need to send is going to be carried at baseband, so I'm not going to put it on any carrier, or I'm going to transfer it on in frequency domain by multiplying it by a carrier sine wave at a certain frequency, right? The data rate is at a certain number of bits per second can be transferred across that medium, okay? If it's wireless, for example, then that wireless medium is going to have certain power limitations, certain bandwidth of communication, and so on. All these things, including modulation, sampling, reconstruction, identifying the physical antenna design, the physical cable design, all these aspects are physical layer aspects, okay? Then comes another layer, okay, which is the link layer, and the link layer is responsible for defining the order and formatting when you are communicating between one node and the other. So the link layer is a single connection layer only. So it talks about just what happens between two nodes that have one common link between them. This is the link layer, okay? So data transfer between neighboring network elements, okay? This is, for example, what is defined in the 82.11 standards about the physical layer. If you go to 82.11, the standard for the Wi-Fi, you will find that they define physical layer, and then the next one, something called the medium access protocol, or the medium access mechanism. That medium access says who speaks when, what is the format of the packet that they exchange, and so on. This is, and it's across one physical wireless link between one node and the other, just one physical link from one node to the other, okay? So this is called the link layer. Now above that, if you want to transfer information from one start point to one end point across multiple links, this is what you do at the network layer. So to make sure that information can be carried from this point until it reaches this point, or the other way around, now you need the network layer. So the network layer defines how you communicate across multiple links until you reach the final destination, which includes what we call the routing mechanism, okay? So at every single intermediate point, which way to go. This is defined at the network layer, okay? In the internet words, this is what you do in the IP protocol. Remember, the internet, people are always talking about using TCP/IP. These are a mix of two protocols that comes at two different layers. The IP, the internet protocol, is the one responsible for handling the functionality of the network layer, the one that makes sure that you can communicate from one node, starting one, to an end one through many intermediate nodes subsystem. Okay? That's called the network layer. The next thing above the network layer is a little bit more sophistication, which is called the transport protocol. The main idea of the transport protocol is how to divide your data, kind of packets, and control the flow of these packets, how fast they can go through the system and how fast they can get into and out of the system in a reliable way. So this means that if you have any error control, it's introduced at the transport layer. If you have something that detects errors and tries to correct them, it's going to happen at the transport layer, okay? And also, there are two general known protocols for the transport layer that belongs to the internet. One of them is UDP, the other one is TCP. TCP is the more famous one, but both are used equally. The UDP is a more simplified version from the TCP. What is the difference between them? TCP has a control mechanism that allows you to slow down the sources, tell them don't send information quickly, okay, to avoid dropping packets. Remember, we said that if the source keeps sending stuff and the buffers are being filled, packets will be dropped. If you don't want to do that, what is your mechanism? The mechanism is to tell the sources, slow down, keep your information now, send it later, rather than sending it and then losing it, okay? So that mechanism is called congestion control mechanism. It's a mechanism to make sure, similar to if you go to a street and then you have an intersection where traffic is building up to a point where it's going to be stuck completely. What would you do? Sometimes one of the solutions is what? You come much earlier than that intersection and then you control your traffic lights so that they open the green in a very short time and they stay red longer, which means that you are controlling the flow of the cars that reaches the intersection to make it slower so that the congestion in the intersection can be relieved first before more cars can come to it. Okay? The other option is to stop completely, but that's a dropping mechanism. Okay? But if you don't want to drop, you want to slow down things. Sometimes you notice that, for example, when you are going to games in stadiums, what they do, when you are coming there and it's becoming really congested at the entrance of the stadium, they route you through a very long walk. You just keep going and coming in front of the stadium, right? But you are approaching the stadium very slowly because you keep going, coming. So they are slowing you down until they relieve the congestion, right? TCP is doing the same thing. It will sense the state of the different links and intermediate nodes, and if the network is close to being congested and delays in the buffers are increasing and the buffers are filling up, it will tell the sources to slow down. Don't send information very quickly. Wait a little bit, right? Keep your information for you now, okay? While the UDP does not do this. It just allows everything to go through, right? So here, the advantage of the UDP is that you can imagine if you have a more complicated mechanism, right, in the TCP that allows you to control the network more, then probably you need more processing time here. So this one is more complicated in terms of processing, but it lowers the probability of packet losses. That's the TCP. On the other side, UDP is a much simpler protocol. It doesn't require a lot of processing, but at the same time, you risk here that if the network gets congested, you will start losing packets, okay? Which one to use depends on your application, how much you can tolerate in terms of packet losses versus how much you can tolerate in terms of delays of processing, okay? So not any one of those is better than the other. It depends on the application, okay? Yes?
But generally, which one is more secure?
Secure, there is no security here. These two things are not concerned with security completely.
Even
They are
though
just...
the UDP doesn't have, say, handshake?
Yeah, it doesn't matter. I mean, they are not targeting security, okay? Those two protocols are not targeting security at all, okay? Then, sorry.
I didn't really get the difference between network and transport. Like I see both of them are responsible for transferring data.
No, but this one is responsible for figuring out which way to go, right? That's the network layer. Transport layer is more responsible for, okay, you figured out the path. Now how this communication across the whole path can be reliable, which includes error control. So if there is an error that happens across the communication, you can detect and fix that error, and includes also things like congestion control. So lowering the packet drop rate and so on. So this is more concerned of performance. This is more concerned of figuring out routes, which way to go, right? Okay. Any other questions? Type. The highest is actually the most that we interact with as users of the internet, which is the application. So the application is basically whatever you are doing there as desired function that you want from the network. So you want to use this network to send emails, then you are using one of the application layer protocols like the SMTP, the Simple Mail Transfer Protocol, that allows you to connect from your node, right, to a mail server, and then you can send and receive emails through that mail server to some other parties, right? So that's a protocol that looks only about how you can put an email composed of text and some attachments, so multimedia, for example, and then put an email address and put a name of a server that allows you to take that email or that piece of information, store it, and then reliably communicate that to another recipient, right? We don't really care about what's happening in the physical layer. We don't really care about how the routes are going to be found. We just care about from me to mail server, from mail server to the other person. I don't care what's happening in between, right? So you are only developing a software for a mail server or developing a software for mail client. That's it. You don't really, when you are doing that, you will never look at what's happening at the IP and the routing, what's happening at the physical layer. Is it wireless or wired? You're not going to write that in your code at all, right? If you are dealing with web pages, then it's an HTTP, hypertext transfer protocol. How you can put like a client that allows you to put a web server address, and then this is going to send the request to the server. And if you are developing the server, how you can respond back by sending the content of that page to the client, and so on, right? So the application layer is the layer concerned about what are you using the network for, okay? And as you can see from the application layer, when I described it, the same can happen at each one of those layers. If you are developing a network driver that is concerned with the TCP protocol and executing it correctly, all what you care about is I'm going to receive from above some content. I don't care whether that content is an email or a file or whatever. I'm going to receive some content, and my job is to take that content, put it in a format which is called the TCP packet format, right? Add to it something that allows me to detect and fix errors, right? And then add to it something else that allows me to figure out if the network is going through congestion or not. Something that allows me to measure the performance as this goes from here to the other side, okay? And then execute the functionality that if I find that congestion is happening, then I need to tell the source, slow down, right? And execute the functionality that if I detect an error, what should I do to overcome that error, okay? That's it. I don't really care about which path the packet took because I'm not network layer. I'm a programmer for the transport. Same thing for the network, same thing for the link, and so on. So the idea here of these layerings is to define certain functionalities, and when you are developing for that or engineering for that, you only care about the functionality of your layer that you are working at. Okay? Any questions? Right. Now, this is the internet protocol. The next one is the ISO. You can notice that the same that like the internet, the same like the internet, the same. They only introduced those two new things. In my opinion, and most of people who are working practically in network development as engineers or as programmers or whatever, it's a sophisticated detail. But anyways, it's there, it's part of the standard, so we have to keep it in mind. Between the transport and the application, there are two things that might happen, right? Sometimes you can just simply put them into the application, but that's what most people are doing. Sometimes you need to separate them and think about someone is developing that part only separate, okay? Those are the session functionality and the presentation. Session is more responsible for figuring out how to synchronize. Synchronize means what? It means me and the other party that I'm talking to, we know exactly where does our piece of information start, where does it end, which part of it is coming with which speed of communication, so I can receive it with the same speed of communication, and I don't mix it up, right? Okay, so that's called the synchronization operation. That is part of what we call the session, okay, layer.
Why can't we do the synchronization in transport layer? Another application?
It's a good question. Again, you can put it here or there, but most of the time, people put it at, put it at the application actually. Most of the time, it's done as part of the application. So the synchronization is more established between the client and the server, rather than leaving it to the protocol part, right? But that's what I'm not, there's no, I mean, if you want to do it with the transport, that's fine. Okay? The other one is the presentation, and the presentation operation is more responsible for if you have any functionality that requires you to change how the data looks like, then that's part of the presentation there. A good example of that, which is mentioned there, if you are doing something like encryption. What is encryption in the essence? You have a piece of information. You don't want anyone to be able to understand it except authorized people. So you take that piece of information, you change it. It looks quite different, which is called encrypting it, right? Or ciphering it, okay? And then only the person who has the method and the key to open this back in its original form will be able to recover it and understand it. Anyone else will see something different that they cannot make sense out of it, okay? It just looks like a garbage or something that doesn't make sense. Or gives a misleading information. It's not the actual information. So now you have changed how the data looks like, okay? That is done by something called, or at a layer called the presentation layer. Another example is compression. Same thing. In compression, you change how the data looks like, but then at the end, you need to recover it in its original form, right? And so on, okay? So again, this can be either done as part of the application, or it can be either done as part of the transport. Most of the time, they do this as part of the application, but most of the time also, it's a separate application from whatever you're trying to do. So the encryption is an app that communicates with an app of your email, for example. The compression is an application, right, that talks to your email client or FTP client and so on, okay? So it's always done as part of the application, but not the same application. Like people work on synchronization applications, people work on presentation applications, or encryption and compression, and then that talks to your client. So it encrypts and decrypts before sending it to the final application client, okay? Any questions, ya shabab hena? Now, the next slide is very important because it shows you actually, and it goes back to the 5 layers because that's much easier to go through, okay? It shows you actually how things are happening, right? So in reality, right, even though each part has been developed by different groups, but when your data is being sent from a source to a destination, it goes through all the layers, right? So it starts by writing your email or your message on WhatsApp, which is an application layer, right? And then I need to send that message, so it needs to reach the other side. What happens? It has to go through transport, which is gonna put it in the format that allows controlling the error, detecting and figuring out if errors happen, right? And cutting it into pieces and sending it reliably to the other side, okay? And then after that, it goes through another, so it takes all what the TCP layer has created, right? Which is what you see here. This is a TCP packet, for example, and then it goes into another packet. So this guy is here, and then you add to it some other things. We call this encapsulation. You put it into another bigger capsule, right? And then now it becomes an IP packet, which includes now information about which path to take, the routing information, okay? Then it has to go through link, because eventually, even though it's going through multiple nodes, in every one of those, it's gonna go through one single link, right? So it goes across the link layer encapsulation, and you see the IP here, and then added to it some stuff. So now you put it in the format that allows you, for example, to exchange it between your iPad or mobile to that access point, right? And then from the access point, it's gonna open it, read what's there, put it in another format that allows it to go through the cable that connects the access point to the server of Qatar University, and so on, right? Okay? And then eventually, for that packet to move from one place to the other, it has to be converted to some electric or electromagnetic signal across a cable or over wireless link or whatever, right? So it has also to go through the physical layer. Now what happens at the end nodes is that you might go across all the layers. In intermediate nodes, it's not the case all the time, right? Because intermediate nodes are not interested in the actual information. They just need to perform their function. Take it to the next part, make sure it goes to the final destination. So that's why in some intermediate nodes, for example, you only process up to the link layer. This guy, for example, is processing up to the link layer. It doesn't really route that, even though they call it a router. But it has only physical wireless connection to each one of those nodes, and it has only one cable connecting it to another bigger box at Qatar University, right? It doesn't really take routing decisions, but those bigger boxes are doing routing decisions, so they go up to the network layer when they are processing the packets that goes through them. Only when it reaches the destination, it will go all the way up to the application, so I can read the email or see the figure or watch the YouTube video or whatever I want to do at the end, right? Okay, clear that anything has to go anyways all the way to the physical. Sometimes in intermediate processing, I don't look at the upper layers, I only process at lower layers according to my functionality, and then when I reach the final destination, I'm gonna process everything back to the application so that I can provide the service to the users. Okay? Clear? Yes.
The last slide you mentioned about the presentation.
Yeah. Again, it just instead of these, instead of application and then transport, you will have two layers here that are doing those functionality separately. Okay? And instead of incorporating them within the transport and the application. Okay? Any other questions? Sorry. Now we are done with general description of the layering model, why we have the layering model, how does the functionality of the layering model in general at a very high level works, okay? Last thing that we will touch upon in this course is gonna be network security. We are not gonna study like security in depth, but we will study some general understanding about network security. And just as a quick introduction to that, or a quick cut through for that, first of all, what are, I mean, I don't like the wording here, bad guys, but anyways, attackers, let's say. So consider me a bad guy. What are the bad things that I can do to your communication and you don't want that to happen to you? Give me general categories, not specific, but general categories. So what? Say something.
And send like a bad data.
Delete.
Send a bad data.
Bad data means what? You have to define the word bad.
You can say corrupted data.
Corrupted data. Okay.
It gives an order.
Is that gonna cause, what's the harm in this case?
For example, I can send a link, but this link is not necessarily what is defined to do. Once someone presses, it will download some stuff.
I can't hear you.
Such as sending a link from one new node to another node or used to user. This link, once it pressed, can download that file.
Okay, so this is, the bad part for you is what?
Speed download is complete.
Yeah, so what's being downloaded to your,
Divide.
so unauthorized access to your device, right? If you want to put this as a general idea, it's an unauthorized access to your device, okay?
Overloading the link
With the target of doing what?
of
correct.
downing it. Of downing it.
Yeah, so we call that a denial of service, right? So I prevent you from getting the service that you want to do by simply jamming you or overloading the link that you use for communication or overloading the servers by sending lots of requests. So that's one bad thing, denial of service. The other thing is unauthorized access, which means breaching the authorization. And that could include many things, right? That could include pretending to be you with the purpose of harm. So for example, somehow I get access to your email and I go to your best friend and send him really a bad email. And then you are no longer friends, right? Because he believes that this came from you. And no matter what you do or you say, you cannot do otherwise, okay? So that's kind of impersonation using unauthorized access or unauthorized access to put harmful information in your place that harms your data or wipe your hard disk or steal your information or whatever, okay? That's another thing. What's the third thing?
Taking this
Data breach,
Which means what?
stealing data, getting access to the routes to steal data which is supposed to be protected.
Okay, so now this is correct. So basically listening to data in an unauthorized way, right? We call this wiretapping. You know what's the meaning of the word wiretapping?
Yes.
So simply this comes from old way of listening to people. I mean, you have a cable that connects your phone at home, right? And that cable goes outside your home, so you don't see it when it's outside. And someone, when they want to kind of, in an unauthorized way, like spy on your phone calls, they will go to the box outside in the street They have a piece of wire, they connect it to your cable, and then they can hear whatever you say and whatever the other party says to you, right? That's wire tapping. Now, nowadays with advanced communication, you do this over the wireless, over the wire, in a more advanced way. But anyway, it's the same concept. I can listen to your information while being transmitted, and I can understand that information in an unauthorized way. You don't want me to be able to listen to that, right? Okay. So either wiretapping, that's one kind of attack, or denial of service, right? I'm not really listening to your information, but preventing you from getting your service, or breaking the authorization or authentication, basically. So it means that I can impersonate you, I can have unauthorized access to your data, I can have unauthorized access to your devices, so I can pull something harmful on those devices, okay? So those are the three types, and I think they are mentioned in the next few slides with nice drawings, but not much. So here it shows you the denial of service attack. So many people are trying to connect to the same server such that the server reaches the capacity. Whenever a legitimate user wants to access the server, they will get either you type the address, for example, and it never responds back, right? Or it responds back saying server busy, try later, right? One of the two, okay? So that means that it's no longer accessible from your side. Something here like the sniffing over wiretapping, so listening to your information in an unauthorized way, whether it's wired connection or wireless connection, right? And again, the sniffing can happen at different layers, so I can listen to this at the Wi-Fi level, or I can listen to this at the IP level, so maybe back when the network, when your data is in the backbone of the network, not in the first access level. You can do that as well. And this one is very nice. It just shows you, I think people who took the communication, the secure communication course might have been exposed to this experience. So over wireless, over Wi-Fi, especially the older versions of the Wi-Fi, you can actually break into the system using an application. That's a free application that you get from the internet. It's called Wireshark. And then you can listen to the packets, and actually you can even break or capture the password that's used to connect to the router, and then you can access the router without authorization, right? So you can use that router as if you are part of the original network, or as if you know the password ahead of time, okay?
How can we do it?
They have been doing it in the other course. I don't know how many of you are there.
طيب هو بس
هو الوحيد هو تلقى.
انا سجن.
So it's a bit longer process, but if you look it up in the internet, you should be able to do it. Okay. Again, it doesn't work with the newer protocols because the method which is described on the internet and the versions of Wireshark are working at earlier versions of Wi-Fi. You can try it if you have one of those older routers, or if you switch back your router to an older technology protocol, right? With the newer ones, it's a little bit more, quite more challenging. It can be done, but it's quite more challenging. Okay.
How is it legal? How is it legal?
You haven't heard of ethical hacking? I will tell you why. Because what we mentioned earlier is when we talked about the attacks, I didn't really give the proper introduction. So when you are working in network security, right, your job is to do what? Yeah. So your job is actually to devise ways to protect the network from those types of attacks. In order to do this job, what do you have to do? You have to learn how these attacks are happening so that you can figure out ways to prevent them, right? So that's the good side. The bad side, if I am a hacker and I'm a bad guy, what do I need to do? I need to learn about all the protection methods so that I can figure out how to break them. And this race keeps on going, right? So hackers learn about new protection techniques, they figure out some ways to break them, and now network security engineers learns about new security breaching methodologies and figure out ways to protect against them, and the race keeps going, okay? There is no such a network that is 100% protected. It's protected as much as possible with very high level of protection, and the attacks are less probable, more difficult, and so on. But it's never that it's impossible to attack a network. It's always possible to find some loophole or some way, okay? And there is no such a thing like an attack that you can never prevent against. There is always a way that you can prevent against existing attacks, and then newer ones will come up and so on, okay? We are done. with what we need to do in this part of the course, the introductory part. And I think the remaining slides are historic. They talk about the history of the internet, how it evolved as some kind of a defense network, and then it became university network, and then that was in the US, and then it became a worldwide network as we see it today. Okay, so I'm leaving those for you.